Yeah, hi there. In this tutorial, we will continue with reading JSON data into Pandas data frame. We did one tutorial previously, so we are just continuing further on it. So again, we are importing first library Pandas as PD. Now this time, I'm using the library URL lib.request. Okay, importing it as request, and then this is the same URL which we used in the previous tutorial. Uh, I'm just using request.url open method and passing the URL and getting the response. If the response code is 200, it means the data, it means the connection went fine successfully. Okay, then we can um, read the data into data object using JSON.loads. And if the response code was not 200, then we are printing that we got error while retrieving the data. Okay, now what we are doing is we are converting it into, or we're trying to flatten it using the method pd.json underscore normalize and passing the data that we had read. So if you see, I'm just and then just displaying the first three records. So in the first three records, we can see the ID, name, username, email ID, phone was fine, website is fine, but for the data which was having the value as an object of a key value pair, that actually got converted into the hierarchical form like address.street, address.suit, address.city, zip code, address.geo.latitude, because this is the same thing that we created in the previous tutorial. Let me just quickly show you. Yeah, this is what we had created. The only difference is in this one, uh, the one which we covered in tutorial 01 pandas reading JSON 01. It was we were using a function that we had manually written, and we were creating the hierarchy and separating the hierarchy names in the columns by the underscores. Same thing is happening here, and however the columns are separated by the dot in this case, so that is fine. Now, let's say we are reading a file which is a multi-level nested data it is having. So I'm reading one file called as raw underscore nyc underscore fill.json. I'm using json.load. I'm storing the data in nyc data. So again, let's first check the type of this NYC data, what it is. It is a dictionary. Okay, since it is a dictionary, so let's see how many keys it is having using length function. So length of NYC data is 1. It means it is having only one key. So what is the name of that key? I can get NYC underscore data dot keys. So the length, so the name of the key is programs. Okay, now it is only one key. So let me check what is the value this key is having. What is the data type of the value? So if I check the type of NYC data programs, then I get a list. So it means this key is having a list as its value. Fine. So let's check what is the length of that particular list so that we can do. Okay, let me add here. I can check length NYC underscore data and programs. So okay, so 13,954. So this list is having 13,954 elements in it. Okay, length of list. Fine. Since these many number of elements are there, so let me see the first element. What is the type of the first element? So how we can go to the first element? Just by using the index reference of 0. So NYC data programs and the index reference of 0 gives the first element of that list, and it gives the first element as a dictionary. So it means this uh, is actually a list of dictionaries. Okay, now since it is a list of dictionaries, then that is each element of that list is a dictionary. Okay, fine. Now for, let's say, for the first element, if I want to see what are the keys, then again we can just simply say nyc data programs 0, which indicating the first element of the list, and then printing the keys using dot keys method. So these are the keys. So these are the keys which are there in the first element. We can also print it out, so using json.dumps and again specifying the same thing, nyc data program 0 and indent equals to 2. So this is what the data that we get. So if we see, this data is like this. It is having, this is the first element only of that list, and there are how many, you saw 13,954 such elements. Okay, fine. So let's see what it is. So I had actually copied this into a notepad plus plus, so let me quickly show you this. So this is what it is. So this is the first element of that list, which is actually a dictionary. So what are the different keys of it? So we saw that it has keys like season. So season is a key and its value is uh, uh, string value. Orchestra, its value is a string value. New York. Okay. Now the third key is concert. So this is the third key, concert. Now concert is having a value which is actually a list. So if I see, this starts here and ends here. So it means this is a list, and within this list the element is a dictionary. So concerts is a key. This key has a value as a list, and the element of a list is a dictionary. And since it is a dictionary, so again it must be having a key value pair, which is in the form of a date, event type, venue, location, time. So it means concerts date, concert event type, concert venue, location, and time. Okay, so the next key was program ID. The program ID is just simply a number in the string format. Fine. Then the next key is works. So works is the next key. Again, works is a key which is having its value in the form of a list. So this list starts here and it goes up to here. Okay, cool. So it's a big list. So what this list contains, this list contains, these are the elements in the list. So each of this element is a dictionary. Now, what are the elements of each dictionary? Like work title, conductor name, ID, soloids, and composer name. Fine. This is the first element of this dictionary. Sorry, this is the first element of this list, which is having key as works. Now the second element of the list which is having key as works is this. Okay. Now if you see in this second element, there is work title, there is composer name also. Here composer name was coming at the last, here composer name is coming as the second key, but that's okay. Conductor name is there, ID is there, soloids is there, so that was empty. Here we are having some values, and then another key is there, movement, which was not there in the previous element. Okay, so likewise there are different elements are present. If I just quickly go through it, the next key is ID, and this is the last key is ID. Okay, so that's how we have covered what each of these keys contain. Again, so basically what we have here is a JSON data which is nested. Nested means that is there would be some keys which are having a values which itself can be in the form of a key value pair. So this is one such key concept which is having a value in the form of a list, and that list contains elements as dictionary which is in the form of a key value pair. Similarly, this works is a key. It is having value in the form of a list. Now each of this element of this list is a dictionary that is having values in the form of a key value pair. Within this dictionary there is a key called as soloids, which is a list, and that list is in the form of a key value pair. So that's how it can go up to um, more levels of nesting. Okay, that is fine. Now we know what the data looks like. So what I am doing is, again, I'm just using pd.json underscore normalize and reading NYC data programs into this data frame and just displaying the first three records. So this is how it looks like. Season is fine, orchestra is fine, program ID is fine, ID is fine. The thing is with the columns concerts and works. So if you see concert, that was there, which is actually a list. So concert is coming as a list. So if you see that this particular column concert is not flattened by pd.json underscore normalize. Similarly, works, which is again contains a list. of dictionaries was not flattened. So what we have to do, we have to flatten it separately. So one thing I'm just first trying to do is I'm trying to find out whether this column ID is unique or not by comparing the length with its unique elements. The length is true, it means it is unique for each of the rows, and I am setting this ID as the index and just displaying the first three records. Setting the ID's index using data frame dot set underscore index and name of the column ID in place equals to true, displaying the first three record. This is how our data frame now looks like. Now what we need to focus on, we have to flatten this concerts column, and we have to flatten out this works column. So what we are going to do, we are again going to use pd.json underscore normalize, and again data is coming from nyc data programs. Now this time we have to specify which column we want to flatten it out. So record underscore path says concert, so this column concerts will be flattened out. What else column we want to appear in this flattened output? One extra column that we want is the id. Meta equals to id, and once the flattened data is stored in concert underscore data frame, I'm just setting the index as it like we did in the earlier case, and just printing the first three records. So this is how it looks like concert. So if you see for the concert, we were having data in the form of date, event type, venue, location, time. So these are all coming now as a separate columns: date, event type, venue, location, time. This is for the first record. Now how we can join or how we can relate this based on the concerts with the main with this data frame nyc underscore df is based on this IDs, because this ID was unique. So using this ID we can uh, join this particular data frame, the main data frame, with the concerts. Next column was the works. So let us flatten out the works also. So using so we're creating works underscore df data frame using, and we are flattening it out using pd dot json underscore normalize, passing the data which was our input data nyc data with the key as programs. Now what we want to flatten out is the works. So let us flatten out the works by specifying it the record path, and I want extra column, I mean additional column, to appear as the id. Again setting the index as the id and displaying the first three records of the work data frame. This is what we got. So what you see now is the work title, conductor name. So in the works we were getting work title, conductor name, it is coming, id is coming, this is id, soloids is coming, okay, composer name is coming, that is fine. Now some other elements of that works were having some extra keys in their dictionaries. For example, if you see this one was having movement, so that is why we are having movement. There must be another one which is having another key as interval, like this. So we have interval, and then there's id, that was already covered. So whatever columns are there are all columns coming. Now one thing to notice that it had flattened the works, but within the works there is another column called this soloids that is not flattened. It is again in the form of a list, so we have to flatten it out. So how do we do it? Again we can use pd.json underscore normalize. Our input data is nyc data programs, record path. Now this exists soloids within the works. So the soloids exist within the works, that is we have to come to works, and within the works we have to go to this soloids. So that is what we have to specify the record path, like how to reach that particular um, column which we want to flatten it out. So go to works, and within works go to soloids, then you have to flatten it out, add additional column id, the additional column that we want to appear as a part of the flattened data. We have to specify that additional column using this meta argument, and we get soloids underscore data frame. So if we compare it, so for the first it was empty, so there is nothing in it. But for the second one, if you see, it was having values like name, roles, and instrument. So you get select name, roles, instrument. ID is the additional column that we had given using meta. So so that we can we can join the record, because ID is unique across different data frames. So so this will act as the key to join the different data frame. That's the purpose of having it. Okay, so let's see. It is having value as Otto, Antonio, role is S, and instrument is Soprano. Again, for the second, uh, you will see soloids. The value is Schaeffer, Berg, William, role is A, and piano. So in this way, we have created another data frame. So now one thing that we have done is in each of these data frames, we have one extra column added, which is called as ID. Again, within this, we can set it as index. So let me just quickly do it. What we can do is SOLOIS dot set underscore index. I'm setting it index ID, and in place equals to true. And then let me just display first three records. So this is what it looks like. So we have created for each of these uh, uh, key value pair structure, we have got a separate data frame, and all of these data frames now can be joined using the ID column, which was unique for each of the records. So that's how we can create multiple data frames using pd.json underscore normalize. Now another thing that we can do, we can apply the same function. Remember in the first lecture we had written a function, a custom function to flatten the nested JSON. If I apply the same flattened underscore JSON for each of the records, then we get the flattened data. And if I display the flattened data, the first element of the flattened data, this is how it looks like. So let's quickly compare this with what we have in the actual source data. So if you see, the source data was season, orchestra, then we have season, orchestra. For concerts, we had date, event type. So now we have concerts underscore zero underscore date. This zero is coming because the concert is having the value in the form of a list. So for list, for what it will do, it will add a number indicating the index of that particular element. So this is the first element of this concerts, and now this first element of this particular list, if you see, it is, so index is 0. So if you see, concert 0 date, concert 0 event type, venue, and location, this is all it is coming, and concert 0 time. Fine. Now next is the program ID, that is fine, single value. Now what about this works? Now works is a list, again fine. So this will start like this: works underscore 0 underscore work title. So if you see, work underscore 0 underscore work title, it goes like that: work 0 conductor name, work 0 ID, work 0 soloists, soloids title. Okay, now composer name. Now this itself is actually a list. So the way it works is, works, it will go from works underscore 0 underscore soloids underscore 0 underscore soloids name. So works underscore, now this is actually in the first element, because the index 0 did not have any element. So let's go to this one. So it will be like works underscore 0 underscore soloids under works underscore 1, because this is the this is the index 1. So works underscore 1 underscore soloids. So we have works underscore 1 underscore soloids underscore 0 underscore soloid name. So works underscore 1 underscore soloids underscore 0 underscore role, and then instrument. So this is how it actually has created the hierarchy, and it can go up to much deeper hierarchy to flatten everything that we have. And if this is what it actually is doing for each of this, and if we create a data frame using this pd.data frame function and storing it in the data frame and displaying the first record, this is how it looks like. So what it did, it actually created I'm just displaying the first three rows. For each of the row, it created 3,295 columns. The reason being, it created these many number of high columns because the level of hierarchy, the level of nesting is too much, and uh, for each level of nesting, it keep on adding new column to it. So we had two approaches that we have covered. One approach, the first approach is for each of this nesting level, we can create different data frames, and in each of the data frame, we can have some ID column which can uniquely identify that row, and those data frames can be joined based on that ID column. So it's like having multiple sub data frames of the original data, and each of these sub data frames can be joined using one specific ID uh, column. Another approach is if we create one big data frame in which all the data is flattened. The only challenge with this approach is that it will have a very huge number of columns. So in case we are doing analysis in such a way that we don't necessarily need all the columns all the time, which we don't need it, then probably we'll go with the first approach. However, if there is a requirement that, okay, you want to display everything at all the time, then we go with the second approach. So that's it for this session. Thank you.